In May of 2023, in what should have been the best part of spring, my eyes were burning and my throat was sore because the air was full of wildfire smoke. All around me the skies were not the bright blue they should have been, but a dull gray, and although I live at the edge of the beautiful Black Hills of South Dakota, I couldn't see any views. It was too early for the fire season to be ramping up. It's not normal, I thought. But it's actually been even more not normal than that. The smoke I was looking at was not from a fire burning in the Black Hills or even in neighboring Montana, but from hundreds of thousands of acres burning in Canada, hundreds of miles away. May fires are not abnormal there, nor really are the fall fires that are still burning now across Canada. But what definitely is not normal is the extent and intensity of Canadian fires this year, still poisoning the air across the country. If you've been paying attention, you'll recognize that there are plenty of other not normal weather stories going on right now, just within this country. The horrific fires on Maui, the historic failure of the Kansas wheat crop, the flooding in Yosemite National Park due to the melting of the winter's unprecedented snowpack across California, the deadly northward and eastward march of Tornado Alley, the coral cooking ocean temperatures all around Florida's coast that are contributing to what's now going on, which is Hurricane Idalia. I don't need to go on. You've seen these stories. The point is, while any one weird weather event can just be a part of normal variability, it's the shifting pattern that makes it not normal. And what's going on now is not normal. That's probably why you're taking this course. You can see that things are out of whack, and it's time to learn a little bit more about what's going on. The hardest thing about trying to make sense of climate change is that it's a huge subject composed of a lot of seemingly little facts, observations, and phenomena. So there's a need to take small pieces at a time while keeping one eye on the bigger picture. For this course, I've tried hard to find ways to integrate the large-scale concepts with more immediate and local applications. So I hope that by the time the course is over, you'll feel you've gained some understanding both of what's happening to the planet and of how it directly impacts you. Before we can understand how climate change affects us, we need a basic understanding of the science behind the whole thing. So let's start by considering this beautiful planet we live on, Earth. NASA estimates that there are at least 100 billion planets in our galaxy. That's just the Milky Way galaxy, mind you. There are lots more galaxies in the universe, but within our home galaxy there are upwards of 100 billion planets. And despite centuries of searching, we've found no reason to believe that a single one of all those planets is capable of supporting life, especially the amazing variety and complexity of life as we know it. So really and truly, this planet is special. One of the most important ways in which this third planet from the Sun is special enough to support life is because of its atmosphere. Earth's atmosphere is a layer of gases surrounding the planet, held to it by gravity. The various gases that exist in the atmosphere do a lot of things for us, but one very important thing they do is to moderate the temperatures we experience at the surface of the planet. If you've ever visited a greenhouse, you will have immediately noticed that it was a pleasant place to be, warm but not too hot, and moist but not too damp. That's because the glass walls and ceilings let the sun's energy in, but trap just the right amount of that energy and water vapor inside. Earth's atmosphere does the same sort of thing for the planet. The atmospheric blanket absorbs the sun's energy, keeping it from passing by or just bouncing back into space. That energy spreads warmth over the entire surface of the planet, and this is what we call the greenhouse effect. Without the greenhouse effect, the average temperature at the Earth's surface would be much colder, likely a little below 0 degrees Fahrenheit, compared to the actual average temperature today, which is around 57 degrees Fahrenheit. That's a big difference right there. And without the greenhouse effect, daily and seasonal fluctuations of temperature would also be much more extreme. The atmosphere is made up of a lot of different gases and other things as well. Mostly it's made up of nitrogen gas, but there are other gases too, like oxygen, hydrogen, and neon. Not all of the gases in Earth's atmosphere contribute significantly to the greenhouse effect. The ones that do are referred to as greenhouse gases. I'm sure you've heard that term. The most potent greenhouse gases, the ones that absorb the most energy, include water vapor, carbon dioxide, nitrous oxide, methane, and ozone. You might hear all of these mentioned in discussions about the environment and about climate change in particular. They're all important and they all contribute to climate change in different interesting ways, but the one that really explains what's going on is carbon dioxide. Carbon dioxide makes up a relatively small percentage of our atmosphere, much less than many of those other gases, including oxygen and nitrogen, but it plays an extremely important role in life on Earth. Plants use carbon dioxide in their process of photosynthesis, where they trap energy from the sun to make food and release oxygen. Animals, including humans, exhale carbon dioxide when they breathe. These processes have maintained a perfect balance on Earth for millennia, allowing life to flourish. But here's where the problem comes in. In the Industrial Revolution, when humans began burning coal and other fossil fuels for energy, the balance started to shift. The carbon dioxide produced by combustion became more than the plants of Earth can suck up in photosynthesis. This has led to a steady increase in the amount of carbon dioxide in the atmosphere. Not a lot, just a little, but it's enough to capture more heat and cause the planet to warm up. Take a look at this famous graph coming from the scientists at NASA, showing the changes in the concentrations of carbon dioxide in Earth's atmosphere going back roughly 800,000 years. You'll notice that there are big, fairly regular swings. The Earth has experienced large-scale cycles in the balance between these important gases. But look at that part on the right, the last 100 years or so. That spike in carbon dioxide levels is far outside the bounds of the cycles the Earth has ever been through in its history. That spike is the increase in carbon dioxide levels in the Earth's atmosphere since humans started burning fossil fuels for energy. The amounts of gas in the atmosphere are measured in parts per million. When I first started learning about global warming, the CO2 levels measured in the Earth's atmosphere was at about 350 parts per million. And this was worrying scientists at the time because the pre-industrial normal level was only about 280 parts per million. Do you know where we are now? In 2022, CO2 levels measured at over 421 parts per million. The concentration went above 400 in 2013 for the first time in human history. So think about that as we move on to the next modules, where we're going to talk about how that extra carbon dioxide in the atmosphere actually changes our world.